So in today's video, we're going to be learning about different types of probabilities. But first, let's just talk about a few definitions that I'm going to be using throughout this section. So the first one is an experiment. That's just a controlled operation that gives you a result. So it could be flipping a coin, it could be rolling a die, it could be the chances it's going to rain, is it raining or not? Anyway, okay, so the outcomes are the possible results of that experiment. So when you flip a coin, you could get either heads or tails. That would be the outcomes. An event is a sub-collection of the outcomes. So again, you could flip it 10 times, or you could just flip it one time and have the event of tails. A sample space is the set of all the possible outcomes of an experiment. So I think it'll just make more sense if we just do a few. So let's say we flip a coin. You have two options. You can either get heads or tails, and they usually make it, my lab usually puts it in a set, so it has the brackets on the end. If we roll one die, you could roll a 1 or a 2 or a 3 or a 4 or a 5 or a 6. We're just doing regular die, just six-sided dice. Okay. If you had a true-false question, you could either have true or you could have false. Now, if you rolled two dice, you could have them both be heads, heads. You could have them both be tails, tails, or you could have the first one tails and the second one heads, or the first one heads and the second one tails. So there are four different outcomes for that. Okay, so probability has two different classifications. One is if you experiment to get it, and that's usually, I'll say usually, written as a decimal. Okay, or it's theoretical. You don't actually experiment, you just sort of think about what could happen, and that's usually written as a fraction. So we're going to start with the experimental, which is called empirical. Empirical or experimental, it sort of helps that they both start with E, right? So empirical probability is the frequency of the occurrence of an event. So let's talk about what that is. And this is the Math Geek formula you would use for it. So if you want the probability something's going to happen, the top number is going to be the number of times that it happened. Okay, and the bottom number is the number of times that you performed the experiment. So you could flip the coin, 5 times, and so the bottom number would be 5, but the number of times, let's say you get a head, that would be the top number. So let's do a couple of these, okay? And I'll also show you how you write it in sort of Math Geek language. So we're going to toss a coin, a fair coin. In other words, if you flip it, it's like half of a chance you're going to get a head and half of a chance you're going to get the tail. So we're going to flip a fair coin 100 times, and 44 times it landed on heads. So we want to determine the empirical probability. So it's what we did, we actually experimented to do that. So the probability of getting heads, so that's the way you could write that, is, now how many times did we flip the thing? Notice we flipped it 100 times. So that's going to go on the bottom, and we got heads 44% of the time. So that goes on the top. And then when we just plug that, it's usually a decimal. So we'll plug that in our calculator, and you're just going to get 0.44 when you stick it in your calculator. So that will be the empirical probability that this coin landed on heads. Okay. So let's rent some boats. From Lake Bowen Fun Rentals. Okay, so they rented 10 kayaks, 14 sunfish, and 6 rowboats. And that was the last 30 boat rentals. Okay, so 30 is the total boat rentals, and we had 10 that were kayaks, 14 that were sunfish, and 6 that were rowboats. So we're going to use that information to find this probability, empirical probability. Okay, so we want to find the probability that the next time we check out a boat, the 31st boat rental, is going to be a kayak. Okay, so the probability that the next one is going to be a kayak is, now how many boat rentals had we already done? And that was 30, right? So we're going to have 30 on the bottom, and then 10 of them were kayaks. So I'll put 10 on the top. And when I plug that in my calculator, I get 0.33333, it keeps going. They're asking us to round it to 3 decimals. So 3 decimals would be that guy. I don't round it up, right? Because this guy is less than 5. So 0.333 would be my probability that the next one I got would be a kayak. Now the probability that it's going to be a sunfish, I still had 30 total rentals, but this time I had 14 that were sunfish. Sunfishes? Yeah. So when I plug that in my calculator, I would get 0.46666 and a whole bunch of sixes forever. And they wanted us to go to the third decimal, which is that one right here. So I'm going to look at the one to the right, and it's bigger than 5. So I've got to round that 6 up. So 4, 6, 7 will be the probability that we'll get a sunfish the next time we check out a boat. And the last one, the probability of a rowboat. Again, we got 30 on the bottom, and then we actually checked out 6 rowboats. So 6 out of 30, when you plug that in your calculator, you get 0.2. And it says round it to 3 decimals. Notice it says if needed, but it's not needed, so it's just 0.2. Okay, so that's the probability that the next one that we checked out, the 31st one we checked out, would be either a kayak, a sunfish, or a rowboat. Okay, so sometimes they can give you data just written in the problem. Other times they're going to give you a chart. Okay, so we're at Pets R Us, and a veterinarian treated a bunch of animals in the chart below. So this veterinarian on that day treated 45 dogs, 40 cats, 15 birds, and 5 rabbits. Okay, so we've got to find out the probability that the next animal that comes in that gets treated is a dog. Okay, well, the first thing we need to know is what we're going to put on the bottom, like how many did they treat. So I'm going to add all those up, and once I add all those up, let's see, I'm going to get 15 here, and that's 105. So this veterinarian treated 105 animals. Okay, so that's going to be on the bottom of every one of my fractions. So the probability that the next one we treat is a dog is 45 over 100. And you just plug that in your calculator, and I got 0.428 something. And let's see, this time let's round to 2 decimals. I have to tell you what to round it to, so this time we'll just do 2. So if I do 2 decimals, then I go to the third decimal, and that's a lot bigger than 5, so it's be 0.43 will be the probability we're going to get a dog the next time. That's the next animal that comes in. The probability that it's going to be a cat, I still have my 105 that I treated, but this time I only have 40 cats. So I'm going to put 40 over 105. And when I plug that in my calculator, I get 380, and I round it to the second decimal. So I'll just drop that 0 off. So it's 0.38. And then the last one that they ask is the probability that we're going to get a rabbit next time. So it looks like that probability should be the least amount, right? Because that's the smallest that we have is rabbits. So 5 out of 105. When I plug that in my calculator, I get 0.047. So if I'm going to round it to this guy, I'm going to look at the 7 and I'll have to round it up. So 0.05 is going to be the probability the next one is going to be a rabbit. All right. So the next one is it's still a chart. Okay, so we've got a pharmaceutical company and they are testing a drug that's hopefully going to bring down high blood pressure. So the drug is given to 500 individuals, so that's important. That's going to be the bottom of all my fractions. So it's given to 500 individuals, and this is what happened. 379 of them, it actually reduced their blood pressure. 62 of them, it didn't change their blood pressure. 59 of them, it increased their blood pressure. So looks like it's a pretty good drug, except for those poor people that it increased their drug. Anyway, so they, if the drug is given to an individual, so based on these numbers, determine the empirical probability that the blood pressure, that person's blood pressure is going to be reduced, the probability it's going to be unchanged, and the probability it's going to be increased. So this time they're asking us to round it to 4 decimal places. So you see that it's not consistent. So, and neither is MyLab. So you'll have to just make sure, MyLab, if you round it to the wrong decimal place, it'll just say it's wrong. So anyway, so just make sure you round it to you read the directions. Okay, so the probability that the blood pressure is reduced, again, we had 500 people that tested the drug, and the amount that was reduced was 379. So then we just plug that in my calculator, and I should get a decimal. Let's see, we said round to 4 decimal places. I didn't have that. So let me, where's my calculator? Let me grab a calculator real quick, and then we can plug it in. Sorry about that. All right, so let me grab my calculator and plug it in. 379 divided by 500 is going to be 0.758. So it can't go to 4 decimal places. So I guess I'd have to add a 0 on it if they want 4 decimal places. All right. Let's see. The probability that it is unchanged, that would be still 500 on the bottom, but 62 over 500. Let's plug that in by 500, and I get 0.124. Maybe I shouldn't round it to 4 decimal places. Let's round it to 3 decimal places. How about that? Let's round it to 3 decimal places. So 0.124. And let's do the probability that it is increased. Once again, that's going to be 500 on the bottom, because that's how many tried that drug. 59 out of 500. So that's going to give me 0.118. So notice it's written as a decimal. Now, we could change it to percentages. We know how to go from a decimal to a percent. So this guy is like 75.8% chance that it's going to help you. This is like 12%, 12.4% chance that it's not. And this is like 11.8% chance that it's going to hurt you. But when they ask for the empirical probability, they want it as a decimal, no percentages. Okay. Now, here's something you need to watch out for. Okay. So in MyLab, when they ask you to find the empirical probabilities, sometimes they're going to give you this direction. Type as an integer or a simplified fraction. So that means it's going to be a fraction. Okay. If they say round to the nearest hundredth, then of course it's going to be a decimal to 2 places. Okay, so you've got to watch the directions to see whether they want a fraction or a decimal. Okay, so we use this empirical experiment. We experiment to find the probability when we can't calculate it theoretically. Okay, and once we do some theoretical, it'll it'll make a little more sense. Okay, so now here's another table. Let's just sort of look at this table for a little bit before we start trying to answer questions with it. This is the educational attainment, how high up you went in education of the U.S. population for ages 25 and over. Okay, so they just ask a bunch of people um, how much high school or college that they had, right? And then they just gathered the data on it. So notice that this is the top one is all the males. So notice 14 out of however many people we got, 14 were male and they had less than 4 years of high school. 25 of them had 4 years of high school only. 20 had some college. 23 had 4 years of college or more, and there were 82 total guys in the that they asked. Okay, and they did the same thing for females. Okay, and they asked 92 females, and then at the end they added them all up. So 29 males and females, 29 of the folks that they asked had less than 4 years of high school. Okay, and 56 had just 4 years of high school, and so on. Okay, and notice that the final thing over here, 174, is the total guys and girls that I asked. Okay, so we asked 174 people total. Okay, so now that we have sort of looked at it, let's see what the questions are. Find the probability using the chart above of a randomly selected American age 25 or over that had less than 4 years of high school. Okay, so they want the probability that the next person we ask had less than 4 years of high school. Well, how many total have we asked so far? 174. So that's going to go on the bottom. And how many had less than 4 years of high school? Notice they did not ask guy or girl. They said how many either. So that's going to be 29. 29 out of 174 had just had less than 4 years of high school. So when I plug that in my calculator, let's see. Let's round all these to 2 decimals. Just start off 2 decimals. So when I put that in my calculator, I'm going to just write down the 6 decimals that the 3 decimals that I get, 0.166. So I'm going to the second one. So I look at that last 6 and it's bigger than 5. So it's going to be 0.17. Okay. So now let's see how many had 4 years of high school only. Again, they're asking guys and girls, so 174, 4 years of high school only, so that's 56 had 4 years of high school only. So when I plug that in my calculator, I'm going to get 0.321. I'm going to the second one, so I look at that little 1 and it is not bigger than 5, so just 0.32. All right. Now this one is how many were a woman that had 4 years of high school or more. Okay, so we're still going to say anybody could walk in to that or the next person they ask could be male or female. Okay, so I'm still using the 174, but we want to find a woman who has 4 years of college or more. So let's see, a woman, so that's going to be that line that has 4 years or college of more or more. So that's what, 22? So 22 over 174. So that's going to be 0.126. And I'm going to the 2, and notice my 6 is bigger than 5. So it's going to be 0.13. All right. Then the last one is the next person we ask, and they didn't say we had to ask all guys. They just said the next person that comes up that we ask. So that means 174 is my total, was a man with 4 years of college experience or more. So A man with 4 years of college experience or more would be that guy right there, right? 4 years of college experience or more. So that's going to be 23 out of 174. When I plug that in my calculator, I get 0.132. So I'm going to 3. That 2 is not bigger than 5. So it's 0.13. Okay. So now there is this theory. It's called the law of large numbers. So if I flipped, let's say I just flipped 10 coins. Okay, I just flipped a coin 10 times. Okay, um, it would be very rare for me to get exactly 5 heads and exactly 5 tails. Okay, um, but it's a fair coin. I don't have it weighted, but it would be sort of rare that I get exactly 5. But if I flipped it 1,000 times, I'm going to get closer and closer to having, closer and closer to having 500 heads and 500 tails. That's what this law of large numbers, it states that the probability, if we, the law of large numbers states the probability statements apply in practice to a large number of trials, not to a single trial. It's relative frequency over the long run that is accurately predictable, but not individual events. So if I flip just one coin, um, on it's going to be it's going to be harder. Or like I said, if I flip 10 coins, it's going to be really hard to get 5 heads and 5 tails. Okay. So we are going to do some theoretical probabilities. Okay. So theoretical probabilities are usually written as, theoretical are usually written as fractions. Sometimes they're not. So, theoretical is not based on the actual observances of an experiment. So we can't actually do some experiments. Some experiments are just not humane to do on people. So we have to do a theoretical experiment. So, you know what? I don't think these are usually written yeah, okay. Sorry about that. Okay, so let's talk about the rain. Okay, when I get up in the morning, I usually go on weather.com and I look and see how hot it's going to be, so I know if I need to bring a sweater or not. And I also look at the percentage of rain to see if I need to bring an umbrella, or do I need to wear sort of boots to teach in, or do I, or can I wear flip flops? What should I be wearing? So, think about the chances of rain. If it says 0 chance of rain, that means it's not going to rain, right? So, I can wear whatever I want as far as shoes go. But if it says 100% chance of rain, then I probably don't want to wear sandals or flip flops, right? Because that means it's going to rain. 50% chance of rain means, it's a toss up. It might rain, it might not. Okay. Um, the the answers to theoretical problems will always be decimals, so I don't need to say fractions. I thought that's why I looked it up. They're usually decimals. Sorry, between 0 and 1. Usually between 0 and 1. So like 50%. Remember when we did our Dr. Pepper? If we want to get rid of our percent sign, we cross off the percent and move it 2 decimal places to the left. So I'm going to cross off my percent and move it 2 decimal places to the left. So it's going to be 0.5. If I did that to 100%, cross it off, move it 2 decimal places, do you see it's a 1? So if the theoretical probability is 1, that means it is going to happen, will happen. Absolute 100% chance it's going to happen. But if it's a 0, it's never going to happen. And that's what's in that little yellow box right there, right? It cannot occur if it's a 0. It must occur if it's 1. Okay, and every probability is going to be a number between 0 and 1, or it could be 0 and 1. In other words, I can't have a probability that is a 2, right? It's bigger than 1. I can't have a negative probability. And if I have the sum of a bunch of probabilities of one experiment, the sum is going to be 1. Like the probability of rolling its weighted die, the probability of rolling a 2 is 0.3. The probability of rolling a 5 is 0.8. You add those together, 0.2, 0.8, you get 1. That would be all that would be on that die. Okay, so let's look at my formula. Once again, the bottom is the number of possible outcomes. So, and then the top is the number of what we're looking for, favorable outcomes. So, and this time we're going to express it as a fraction. So you just have to read the directions to see how we're going to express it. But okay, so all right. So if a fair die is rolled, let's determine the probability that we're going to get a 2. Now, it is a regular die, so here's my sample space. I could get anything from 1 to 6. If I roll it one time, I'm only going to get one number, right? So the probability of getting a 2, if I roll it one time, I have 1, 2 over there. That's it. So it can happen one time out of, and we have, let's see how many we have over here. 1, 2, 3, 4, 5, 6, right? So 1 out of 6. So the probability, I should say that, the probability of getting a 2 is 1 out of 6. Okay. Let's talk about the probability of getting an even number. Well, let's count my even numbers. I've got a 2, I've got a 4, and I've got a 6. So how many of those are even? 3 of them are even. So the 3 goes on top. That is my favorable outcome, what I'm looking for. And it's out of 6, right? Because we had 6 in that sample set. So the probability of getting an even number is about half. Half the time you're going to get an even, half the time you're going to get an odd. Let's see the probability of getting a number greater than 3. Well, if I look over here at my sample set, how many are greater than 3? 4, 5, and 6, right? 4, 5, and 6. That's greater than 3. So 3 of them are bigger than 3. Of course, 3 of them are less than 3. So that's still a half. All right, now let's look at the probability of getting a 7. Well, if I look over here at my sample set, how many of those are 7s? Like if you roll a die, do you have a 7 on a die? We don't have a 7. So none of them are 7s. So the probability that you're going to get a 7 is you don't have it. It's 0. Because it can't happen. We don't have a 7 on a die. What's the probability of getting a number less than 7? Probability of less than 7. Well, let's count how many we have over here that are less than 7. Well, I've got 6 of them over there, and all 6 of them are less than 7. So 6 out of 6 is 1. So if you roll a die, you are going to get a number that's 6 or less, 1 through 6, right? So this is one. So this is an example of something that can never happen. Never happens. And this is an example of something that always happens. All right, let's get a little more convoluted. We're going to have a chart now. So this is the name of 9 birds and what they like to eat, their food preferences. And they're listed in this table. So what we're going to do is we're going to take those birds, all 9 of them, because there's 9 of them, and we're going to put them each one on a slip of paper. So I have a slip of paper that says American Goldfinch, and a slip of paper that says Blue Jay, and a slip that says Chickadee, okay. So I have 9 slips of paper, and I put them in a bag, and I shake them up, and I pull out one slip, okay. And they want to know what is the probability that we are going to, let me circle it, sorry. What is the probability that we are going to get a finch? Okay, any type of finch. What's the probability of getting a finch? So, probability of a finch. Now, how many birds did we have in that? In there, in slips of paper. I've got 9. So that's going to be the bottom. Now let's go through and count how many finches we have. Got a goldfinch, blue jay. Let's see. Do we have another finch? Oh, we got a house finch. Is that it? Just 2 kinds of finches? All right. So we just have 2 kinds of finches. So that's just going to be 2/9, and we're just going to leave it. Okay, leave it as a fraction. Okay, let's see the probability that it's going to have a high attractiveness to cracked corn. They like cracked corn. All right, now we know that we have 9 possibilities, right? 9 in there. Let's find here's our cracked corn, right? So let's find the high cracked corn. So there's a high cracked corn. Is that it? Only one. That's the common grackle. Anyway, only one of them is attracted to cracked corn. So that's just going to be 1/9. Let's look at this one. The probability that a bird has a low attractiveness to peanut kernels, a low attractiveness to cracked corn, and a high attractiveness to sunflower seeds. Now let's hope they put them in order. Did they put them in order? Yes. Peanut, cracked corn, and sunflower seeds. So it said what? That the probability that we're going to have a low attractiveness to peanut kernels, a low attractiveness to cracked corn, and a high attractiveness to the sunflower seeds. Okay, again, we've got 9 over there. Let's go find however many have low, low, high. So let's look for low, 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 high. Well, there's low. The first one, the first one is low, low, high. Do we have another one that looks like that? The next one that's low is this guy. That one is low, low, high too. Low, low, high. The next one is low, medium, so it's not going to be that guy. Low, medium, not that guy. Low, low, high. That guy. So we have, So we have, 3 of them that have the low, low, high attractiveness. So that's going to be 3 out of 9. Now that we can reduce. So if you can reduce it, we're going to go ahead and reduce it. Okay. So the last one is we want a bird that has a medium attractiveness to either peanut kernels or cracked corn. So let's see. So we're looking for probability of a medium for peanut or cracked corn. One or the other. Okay. So let's go through, and there's a medium for peanut butter. There's a medium for cracked corn. Here's a medium for peanut butter. Here's another medium for peanut butter. So medium for cracked corn, medium for cracked corn. So it looks like 1, 2, 3, 4, 5, 6 of them. 6 of them. Yeah. So 6 out of 9 have a medium attractiveness for peanut butter or cracked corn. So I'm going to reduce it. So 2/3 would be the probability of getting that. So I want you to be able to read a graph and find out and answer these questions, these probability questions. And notice, okay, let me keep going. All right. So a ton of questions are going to be asked using cards. And I just want to take a peek at what a typical set of cards looks like. When I was going through college, they didn't really give us a little play by play for cards because we played cards because we didn't have video games. So, whenever you're talking about a deck of cards, you know that there are 52 cards in that total deck. Okay, so 52 cards are in your deck. And now, if you play cards, just give me a minute or two to explain this. Okay, so you've got four different suits. These are called suits. And notice there's four of them. We've got hearts, clubs, diamonds, and spades. Hearts, my clubs. Well, you can see the picture. That looks like, St. Patty's Day. Diamonds, actually diamonds. And a spade, to me, looks like a shovel. And a spades. Okay. So in every single suit, you have the same thing. You have an ace, or you could think of that as a one. It goes from 1 all the way to 10. Whoops. 1 all the way to 10. Every one of them have that. Ace, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And every one of them have a jack, a queen, and a king. Okay. These guys, the jack, queen, and the king, all of these are called face cards because they have a face on them. Okay. So those are called face cards or picture cards. I always call them face cards. But anyway, that's the jack, queens, and kings. Okay. Notice that you would have like 6 of one number. 6 eggs. I mean, not 6, 4. Sorry. You have 4 sixes. You got 4 eights. You got 4 threes, right? Because you have one of each suit. Okay. So let's answer some questions now. Okay, so I just sort of went through. Oh, yes, I should mention this too. The hearts and the diamonds are the red ones. So if you printed this out in black and white, you probably can't see that. And these guys, the clubs and the spades, are the black ones. Okay, so 2 suits are red and 2 suits are black. So half of your cards are red and half of your cards are black. Okay. I'm thinking that that's all of them that we've mentioned. Okay. Um, okay. So I'm shuffled up my deck of cards and I'm going to pull one card out. Okay. I need to determine the probability that that card is an 8. Okay, the first one says that it's an 8. So the probability it is an 8. Well, how many cards are in the deck? We got 52 cards in the deck. Now let's go up and count how many 8s we have. That's these guys, right? So we have 4 8s. So if actually 4 divides evenly into 52, right? And it goes into it 13 times. So the probability of getting an 8 is 1/13. Now let's do the probability that it's not an 8. So it's everything but 8. So 52 is my total, but I'm going to take away 4 of those, right? Because 4 of them are 8. So 52 minus 4 of them is going to give me 48. So I have 48 more cards that are not 8s. Now, when I divide 48 and 52, I'm just going to divide them both by 4 because 4 goes into both of them. So that's going to give me 12/13. Now, one thing I want you to notice with these guys, see, this is 1/13. This is 12/13. Those are sort of complements of each other. We talked about complements in sets, but, um, you know, um, if you add up all the ones that were 8s and all the ones that weren't 8s, we would get 52. We would get everything, right? All right, so now let's talk about the probability that it is a club. And when you look up here, the club is that, and you can write club if you want, but it's that little shamrock looking thing. Okay, so we still have 52 cards. How many clubs did we say that we had? If I counted all of these guys, all of these cards, there are 13 of those cards. Okay, 1 through 10, and then my Jack, Queen, and King. So there's 13, and you can just count them, but there's 13 of them. 13 out of 52. And so that is going to be 1 over 4. And that makes sense because, there's only 4 suits. There's only 4 suits. So one of those suits, clubs, is going to be 1/4 of all the decks, everything that we have. Now, they want to know the probability of a face card, or they call it a picture card. Either way, face card, picture card, jacks, queens, and kings. So again, we got 52 total cards. Let's go up here and count how many jack, queens, and kings we have. So we've got 3 in each suit, and we got 4 suits. So that means I could count them all, or 3 times 4, that's going to give me, what, 12? I've got 12 face cards up there. So 12 out of 52. Let's see, I'm going to divide by 2. I might be able to divide by something else, but I'll divide by 2. So 6 over 26. I could divide by 2 again. So I could have divided by 4. Anyway, that's going to give me 3/13. 3/13. So that's the probability of a face card, 3/13. Now the probability that I'm going to get a heart and a spade. A heart and a spade. In other words, I get one card and it has both a heart and a spade on it. Well, I can't. It's not. It's going to either have a heart on it or it's going to have a spade on it. So 0 of them, 0 out of 52, I can't do that. I can't get one card that has a heart and a spade. Okay. Let's find finally the probability that we get a card that's greater than 5 and less than 4. Greater than 5 and I said 4. I meant 9. I'm sorry. Greater than 5 and less than 9. So it's in between 5 and 9. So let's come up here and let's shade it. Greater than 5, that's going to be 6. And less than 9, let me erase that little 8 thing here. And so it's going to be these guys right here, right? All those cards between that are 6, 7s, or 8s. And there are 3 of them in each set, and there's 4 sets. So again, that's going to be 12 of those guys. So we're going to have 12 out of 52. And we reduced that before? Yeah, 12 out of 52. We're going to have 3/13.